Until now, last-mile network capacity has been the big bottleneck for delivering premium digital services. DSL and cable modem systems, today's most common last-mile solutions, certainly represent a major advance over 56K dial-up modem technology, but both have significant limitations. Cable modems use a non-switched architecture designed for simultaneous broadcasting to everyone on the network. So, information sent by a user competes with everything else on the entire network, even if it's just going across the street. With so much information being sent network-wide, traffic backs up, security is compromised, access is limited, and speed is reduced dramatically, from an advertised maximum speed of 10 megabits per second to only 1 megabit per second or less. DSL uses existing analog copper phone systems, a technology never designed for broadband digital traffic. DSL capacity degrades significantly with distance. Its maximum speed of 7 megabits per second is only available to subscribers within approximately 3,000 feet of the central office. Beyond that, most customers get less than 1 megabit per second service, and 30% of homes and businesses are geographically unable to get DSL service at all. Both cable modem and DSL networks are asymmetric, meaning they cannot fully support applications requiring equal downstream and upstream speeds. So, these systems simply can't deliver bandwidth-intensive two-way services like virtual private networking and video conferencing. DSDN switches and switched network architecture provide intelligent, efficient bandwidth and traffic management. To prevent congestion, DSDN technology routes data packets intelligently within the network. When a user sends information, the DSDN network selects the shortest, most efficient path and routes the packet to its destination. This destination-specific routing also enhances network security. If one area of the network is experiencing high traffic, packets may be rerouted through areas of less traffic using redundant links between the nodes. Even if a cable is cut, DSDN's multipath routing capabilities easily detour around the affected area to deliver continuous service. Unlike cable modem systems, which transmit every communication network-wide, DSDN routes internal network traffic directly from its origin to its destination, making DSDN the most efficient peer-to-peer solution available.
Welcome to the world of limitless opportunity. Hundreds and thousands of data points collated and seamlessly shared at lightning speed to a central cloud, feeding the creation of sophisticated on-demand simulations, highly detailed synthetic worlds, accurate virtual models, a perfect digital twin of anything you can imagine. The Internet of Simulation is your passport to a world of possibilities. A smart testing and analysis platform with the power to predict behavior and deliver in-depth, actionable, intelligent insights. Do you want to make your city smarter? The data collation and analysis capabilities of the Internet of Simulation offer untold opportunities. In a warehouse, simulations forecast the best route through the system, exploring thousands of possible scenarios, compared against live data cues from cars, buildings and people, creating a logistical, virtual roadmap, predicting outcomes, enabling smart decisions, identifying the most efficient, cost-effective path from warehouse to delivery point. Do you need a deeper, on-demand view of your data? As systems get more connected, the Internet of Simulation enables faster modeling of the whole network, from device to cloud, creating a chain reaction of processes, drawing power from miles away, exploring all these simultaneous events that can be tracked and analyzed in a virtual world of complex data, pulled together into place for a clearer, bigger picture. Do you want to improve manufacturing processes or accurately calculate premiums? A car is manufactured from thousands of parts, shipped in from worldwide suppliers, each part with a history and behavior, in a simulation shared over the cloud, which are brought together using co-simulation to create a digital twin that's augmented with driver behavior and car performance, where everything is recorded, analyzed and predicted, allowing the premium to be adjusted as things change. Can you begin to imagine the potential of these groundbreaking digital twins? What opportunities and safeguards could this unlock for your business? Are you ready to unlock the power of the Internet of Simulation?
You've probably heard about it. And you may know that today's architects, engineers, construction professionals, and owners are using BIM from small or seemingly simple projects, like a building or roadway, to complex, multidisciplinary projects, like a major urban development, and everything in between. But what is it? What is BIM? BIM, Building Information Modeling, at its core, is a holistic process for creating and managing project data within an intelligent 3D model. From plan and design to build and operate, it's much more than a single tool or technology. It's the foundation for digital transformation in the architecture, engineering, and construction industry. With BIM, project teams can collaborate in a shared cloud-based environment. BIM allows teams to create a dynamic 3D model of all the data associated with the project, capturing all physical and functional characteristics and relationships for buildings and infrastructure. Everyone on the team can access all essential data in real time to collaborate more easily, to use simulation and analysis, and convey design intent to improve designs, quality, and client satisfaction. And with today's critical need for sustainable construction practices and eco-friendly structures, teams can efficiently explore a wide range of options and develop innovative strategies to deliver comfort, performance, and energy savings. BIM enables close collaboration across design and construction teams, which can help reduce errors and rework and help teams achieve improved timelines, cost savings, and better project outcomes. Innovators like you are shaping new possibilities, moving ideas and designs from 2D to 3D and into the cloud, collaborating smarter to create solutions that the world needs today and tomorrow. And that is the power of BIM.
BIM, or Building Information Modeling, has been making headlines across the construction industry for some time now. You might have read about it in construction magazines or heard about it during engineering or architecture conferences. Some of you might already be using BIM for your projects. We thought it would be a good idea to make a short video about what exactly building information modeling is. and how it is useful for engineers, architects, and construction professionals. To explain the video, we have used simulations that were kindly provided by the cloud-based simulation provider, SimScale. Let's start with the basics. What exactly is Building Information Modeling, or BIM? In simple terms, BIM is a digital representation of a building's physical and functional properties and characteristics. BIM goes further than just a building's physical appearance and includes information about every component that goes into a project. This helps the designer, whether it's an architect, engineer, or construction professional, to create and design more effectively when compared to other tools on the market today. Every component of a building is essentially a BIM object. This means you could take a window, a door, or an HVAC system as an example, and the file will tell you the product's properties, like thermal performance, its physical characteristics, a graphical representation of what the product actually looks like, product's functional data, allowing the user to manipulate the object the way it was intended to be used. So we can say that BIM is first and foremost a process, but it's much more than that. BIM is a 3D modeling based process that provides architecture, engineering, and construction professionals information and tools to efficiently plan, design, construct, and manage buildings and structures. The essence of the BIM process is that it enables the creation of virtual 3D models that can be explored and manipulated, making it easier to understand the relations between spaces, materials, and systems. A database generates a 3D image and creates building plans. Thus, the BIM process can build, view, and test a structure in 3D. These abilities allow revisions and the assembly of accurate details. The detailed data permits design, clash detection, cost, and scheduling. Each of the stages of design and construction benefit from its involvement in BIM. The most known BIM software solutions are Revit, Navisworks, Autodesk BIM 360, SketchUp, as well as ArchiCAD and Vectorworks Architect. As technology continues to advance, computer-aided engineering (CAE) software is also becoming part of the construction industry. CAE, also called engineering simulation, is being used by engineers and architects to predict wind loads on buildings, ensure pedestrian comfort in urban areas, validate HVAC systems, control air quality and contamination in clean rooms, laboratories, or underground spaces, predict smoke spread, and optimize thermal comfort. Although not usually integrated with BIM software yet, simulation tools are becoming more and more accessible through cloud computing. Here are a few applications. HVAC system. This video shows the comparison of two ducting designs that were simulated for an inlet velocity of 5 meters per second with the SimScale platform. The blue region on the velocity bar represents the low velocity region, while the red region represents the high velocity region. The first design is an unoptimized one which has sharp angles, while the second design, optimized, is a more curvy one.
You probably know Vistaprint for business cards, but did you know we also print that, and that, and that?
Pedestrian wind comfort. The Flatiron building in New York generates very strong winds. The building splits Broadway and Fifth Avenue and sits at the end of an open corridor created by Madison Square Park at the north. At this location, winds tend to be very high. In the case shown, the wind flow direction is from the north, but slightly aligned with the Broadway street. This produces the most interesting effects as the flow encounters the unique front shape. The animation kindly provided by SimScale shows the flow speed, where the red color shows the higher flow speeds. In these conditions, the wind gusts reach the front leading edge / cone shape of the building that creates accelerated flow and vortices on the Broadway and especially Fifth Avenue side. Wind loads on buildings. We can see the main effects of the structure optimization in this animation that shows the flow physics at 3 different cross sections along the height. Close to the base height level, the area is the largest, and so is the wake behind the structure. but the corner softening helps to avoid strong vortexes. At mid-height, the cross-sectional area not only decreases, but also changes between symmetric and non-symmetric form. In this animation, a non-symmetric section is highlighted that shows non-coherent vortex shedding. This helps to spread out the frequencies along the height and avoid a single dominant oscillation. At the very top, the wind speeds are the highest, but as the cross-section area is rather small, due to tapering, the forces are thus small also. Combined together, the structure is very well optimized with wind loading and is effective in taming the wind.
What if you could build your own city? A place where every child can find nurturing people to help them achieve their full potential. A place where every adult can access job training support. Where health education is abundant. Where social justice ruled the land. A place without limitations. Welcome. You have arrived at STEM City USA. It is what every city should be. A safe and trusted community where you find people and resources to help you become everything you are and beyond. STEM City is unlike anything you have ever experienced. It is a digital twin of the world around you, only better. STEM City is about energy and soul renewal. It is more than a digital world. You can almost feel the power of live cultural events, music, and theater. STEM City promises a better future for children with caring mentors and hands-on activities with dedicated tutors to support our youth. STEM City is your passport to a healthy lifestyle with weekly events addressing our community's many issues. STEM City is your financial well-being with helpful information on wealth management, career advancement, job training, and so much more. STEM City is the community you deserve. It is the city where your dreams can come true. STEM City USA, a place in the sky that is accessible to all who reach for the stars.
On Thursday, July 25th, I had the privilege of witnessing Kansas City, Kansas Mayor Tyrone Garner present the key to the city to Mr. Edward Dwight Jr. Mr. Dwight holds several remarkable distinctions. He was the first African American astronaut candidate, the first African American graduate of then segregated Bishop Ward High School in Kansas City, Kansas, and currently, at 92 years old, he is the oldest man to have journeyed to space. Despite facing political and racial obstacles that prevented him from becoming the first African American in space, Mr. Dwight's resilience and humility shine through. During his acceptance speech, he emphasized the importance of moving forward, overcoming challenges, and remaining humble throughout life's journey. His story deserves to be heard across the United States as it serves as a testament to the perseverance and the pursuit of dreams. May Godspeed accompany Mr. Dwight, and may God continue to bless the United States of America. And Mr. Dwight and the team at the Space Race, thank you as you helped us send these young people to Atlanta, Georgia to attend the National Society of Black Engineers Convention, where they won, they networked, and they found other mentors like you.
Kansas City is in my blood. And if it wasn't for Kansas City, no. I mean, did I?
You had to make sure it got in space.
No, but if it wasn't, there were two factors that allowed me to take life by the neck and go for things. And one was my mom, Georgia Dwight, who a lot of you in the audience had affiliations with. But she was an incredible visionary. I'm not going to make this long, I'll make it as short as I can. But she was an incredible visionary, starting me at school at Keeling in preschool when I was 2. All kind of creative art classes on the wide some Quindera. When I was 4, library card, and it was very, very fascinating about this library card stuff, because my mom looked like she was white. And we went down to the public library on Minnesota Avenue, and they wouldn't give me a library card because they couldn't give a library cards to the colored kids. So I ended up she referred us to Northeast Junior High School Library and said, we think he can get a card there. So I went up, and they didn't want to give me a card because I was only 4 years old. And so my mom rebelled and said they thought I was going to tear up their books. And she says, no, he'll be your best customer. And it turns out that I was their best customer. And there's an interesting story about life and how life works. At Northeast Junior High School, because of the art thing that Mom had me got started, I was going there studying all the great masters in the Renaissance times, because I wanted to be a painter like all these great Michelangelo and all those guys. And at 8 years old, the war started. And they put a packet of 7 Army Air Corps manuals in that library. And out of curiosity, now you got to understand that I had been going to the Fairfax Airport, which was a walking distance of my house, since I was a little bitty kid, 2 years old. Mom introduced me to flying and all that kind of stuff by going to the airport. So I actually worked at the airport as I was one of their mascots, cleaning the airplanes for airplanes that were flying out west to go hunting. I cleaned the airplanes when they got back from these hunting trips. And they paid me a nickel or a dime. And I said, God, I thought about this flying thing. I wonder how this flying thing works. When I cleaned the airplane, the whole bottom of these steering wheels were filled with beer bottles. And And I said, God, I hate beer. And I looked at I hate beer, so I'll never be able to fly in a gotta drink beer. But what ended up happening when the war started, I was about 8 years old when the war started, they put a group of 7 manuals on how to train pilots for World War II. And out of curiosity, I checked those books out, and I had them on permanent checkout. And I was reading these books. Meantime, time passes on. For 8 years, I'm reading these books and going over the tests in the back of each chapter of these books. So I'm now in junior college, and Mom got me two paper routes for the Kansas City Call and Kansas City, Kansas, when I was, and I threw papers all the way through college, by the way. And so on my call paper route, I was in school, and I went to pick up my call papers, and lo and behold, on the front page above the fold was a picture of Dayton Ragland, who was from Kansas City, and he was a jet pilot flying in Vietnam, or Korea rather. And I looked at that thing and I said, my God, they're letting black folks fly airplanes. So I went down and I applied for pilot training immediately, because I really didn't think that they were letting I didn't know anything about Tuskegee Airmen. And so I said, man, they're letting blacks fly. And so I went to the recruiting office, they kicked me out, they told me I was too short, and I stuttered, which was true, by the way. But I wrote to Pentagon, and I said, I want to fly. And Pentagon wrote me back and sent a team to my college. I was the first in line, and he sent me to Denver to test for pilot training. It was a 2.5-hour test. I sat down, and I said, you know, I've seen this stuff before. And lo and behold, the same questions at the end of each chapter. It was a 2.5-hour test. I finished it in about 25 minutes. And I walked up to the guy, and I gave him the test. He said, well, too hard for you, huh? And I said, no, I think I might have missed 2. And that was true. I missed 2. And they carted me off to the Air Force, and that was the start of my career. But that was, to me, that was Kansas City. And that's what Kansas City represented to me. And all the opportunities, going to Bishop Ward was a quiet reward in itself. Because what it did to me, I was out there with those white kids, and all of a sudden I began to realize that they weren't any better than I was. And so I found out that I was on an honor roll, and both me and my sister Rita were honor students out there. And I saw myself being able to compete on an equal footing, so I was never afraid to go out in the universe, because there was nothing that told me in my head that I was not as good or better than the average person. And the white folks did not fear them. I was not apprehensive about being around them, and it allowed me to compete with them on an equal footing, which in order for me to become an astronaut guy, and that's another long show we can't get into today because we don't have time, but there was so much politics, and it's a really incredible story about how I got there and the need in this country for engineers and scientists, because that's why I was chosen as a black astronaut to increase, to make available more engineering and science careers and jobs for black folks. And that's what the whole thing was originally about. And that's why I was not angry that I didn't go up in space, because my job was to put it on the minds and open the conversation in America, and open the conversation to the black community especially, that we can do things. And that's what the whole thing was, and that's what my life has been about. All the things that I've done, it has to do with allowing the historian part is to tell the white folks that we did something. We didn't come over here and get on welfare. I mean, we did things, and that's what those 132 memorials that I have across the country and in Canada are all about. And they're educational, they're large, and white folks get more out of these things than a lot of our black communities. So I want to thank the Mayor Garner for staging this event. I want to say there's a song that say, "I'm not worthy." Big song, and I don't want to get up and say I'm not worthy, but Lord have mercy, this is really overwhelming for me. I've gotten a lot of awards in my space, but from Kansas City, it's a totally different deal.
When you have access to information, you can make better decisions if you can process the information. So the thing that I desperately want communities, especially in low-income areas, to realize is that you have everything you need to solve your own problems within your community. I desperately want communities, especially in low-income areas, to realize is that you have everything you need to solve your own problems within your community.